Good morning. All right, we are on the last part of investigation 5, and this deals strictly with circles, analyzing circles using the Pythagorean theorem. Now, why is this important? Because this is where we derived the equation for the equation of a circle, which is x squared plus y squared equals r squared. And this is the x coordinate plus the y coordinate equals the radius squared. Looks just like a squared plus b squared equals c squared. So I've got 3 different examples I'm going to run through with you right now. And expressing your answers in either, let's call them long form radicals or simplified radicals is dependent upon what the question itself is asking. So I'll get to that in a minute. So first things first, it doesn't matter if this is a positive positive, negative positive, or negative negative. You're still going to do the same thing because you know that a negative number squared is always positive. Just like a positive number squared is also always positive. So again, you're allowed to ignore the fact that these are negative sometimes and just go from there because you're essentially trying to find the radius. And these drawings are pretty bad, but imagine these circles were perfect. There's the radius, and there's the radius, okay? Now, let's figure it out, all right? Here's how you do it. You simply just take the x-coordinate, square root plus the y coordinate squared, and that's how you find the radius of your circle. Pretty basic. So 6 squared plus 10 squares equals the radius squared. So I got 36 plus 100 equals the radius squared. And I got 136, well, square root of 136 equals r. Now, in a situation where if I'm asking you guys what's the radius of this circle, just the straight up radius, I would expect you guys to always simplify your answers, okay? And you can write it in a simplified form, and we know that this divides into a 4 and a 36. I am not right, it's 4 and a 34. Sorry about that. So this would be 2 radical 34 equals r. There's the radius. Now, you got to know when it's practical to do this, when it's not practical to do this, because what if I asked you guys to find the area of this circle? Well, you got to use the area formula, which is pi times radius squared. Well, this is a lot easier if I just leave it in straight radical form because I know any radical squared is just the number under the radical. So just do that. So the area equals pi times square root of 136 squared. So an appropriate answer for something like this, you can just, instead of changing pi to 3.14 and then multiplying 3.14 against, because we know square root of 136 squared is simply 136 pi. You can leave your answer like this because this means whatever the area is, it's 136 times pi. And we know that pi is an irrational number. So there's no point to change it to a decimal. Just leave it in clean form, okay? No need to estimate it because from this point on, all you got to do is use the calculator, and I don't care what the calculator can tell you. So that is that. Now let's do another one, okay? And these are pretty basic, so you guys have such a solid understanding of the Pythagorean theorem that hopefully this is as easy as it looks because you're ultimately just taking, there's the radius, so you're doing the x, y, and that's why it's given to you. So we would do negative 8 squared, but we already know negative 8 squared plus 4 squared is going to equal r squared. We know this is a positive 64 plus a positive 16 equals r squared. 16 plus 64 equals 80 equals r squared. We would square root both sides. This would simplify if I ask you for just a straight up radius. This has an 8 and a 10. Or better yet, a 4 and a 20, or better yet, well, an 8 and a 10 has a 4 and a 2, and a 2 and a 5. So here's why I'm doing all this. I know the 4 comes outside as a 2, right? I also know that 2 times 2 is 4, so this 4 also comes outside as a 2, so 2 times 2 is, I got 4 radical 5, left over on the inside, equals my radius. There's my radical form radius, but again, if I wanted to find out what my area was, which I might be asking you eventually, we know this is pi times radius squared, A equals pi times the radius. Just leave it in radical form because this makes your life a lot easier. right? Because then we just get rid of that square root sign, so the area is 80 pi, and we are all done, okay? So there's that. Going from there, right here. Last but not least, the third one. Look at math make sure it makes sense. I do. Found the word of math. Last but not least, we got -5 squared plus -2 squared equals r squared. We know this is a positive 25 plus a positive 4 equals r squared. And then we just take this. We got 29 equals r squared, square root both sides. This is a prime number. So my radius equals radical 29. I can clean it up. And again, if I were to ask to find the area of this, again, just a equals pi times radius, which is radical 29 squared. We just square this. This becomes a equals, and this is why we don't need our calculator anymore, guys, because you're smarter than this. We don't need the estimated answer. The final answer is 29 pi. Okay? This is what you'll be seeing in today's work for the most part, but it's a culmination of what we did the past couple days, tying in more Pythagorean theorem stuff. And I will see you guys in class.